My name is Abhijit Fanse from Unity One Cloud, and today I'm going to go through a customer case study in which the customer wanted to deploy multi-region production and active-active DR, which was achieved by implementing Service Mesh with Google Anthos Service Mesh Manager and a modern DevOps. In this case, the customer has a traditional three-tier application with React, JavaScript front end, a Django application, and a production database using PostgreSQL and a payment gateway. And they were implemented with in a private cloud on the West Coast in a private data center. They had limited DR with their database being replicated in another data center in an active passive configuration. The customer had high security requirements. They needed PCI and NIST 853 compliance, which is delivered through integrated audit monitoring and compliance solution managed service. The customer also was growing. They wanted to actually serve their customers across the US with lower latency and high performance experience. And they wanted multiple regions, particularly in the US Central and US East Coast. They also wanted an active-active DR solution so that they had true service resilience across all layers of the service. And they also wanted a staging environment where they could actually test out their code in as real an environment as possible before they actually took their code into production to give them the best and the fastest deployment to production. For this customer, we implemented all of what they needed in a very optimal manner by deploying multiple regions. We continued to deliver their production in a private data center on the West Coast. We delivered a solution for them on GCP in the US Central region and another deployment for them in Amazon in the US East region. All these three sites, the US West, US Central, US East, were active production sites, but we also delivered true service resilience by implementing Service Mesh and by taking their traditional three-tier application and breaking it into three service layers, one being at the front end, the web front end layer, the second layer being their Django application, and the third being their database, the PostgreSQL database. And Envoy was implemented as a mid-car proxy, and Anthos Service Mesh was implemented to deliver service resilience across service layers and across regions. In this case, Anthos Service Mesh Manager was used to implement intelligent traffic management and global load balancing between their three production sites on the US West, US Central, and US East. And we also implemented intelligent traffic mirroring so that their staging environment was seeing mirrored production traffic so they could test out their code in staging under the true conditions of production for an easy, efficient, and successful deployment into production. This implementation was done using Unity. Unity is a multi-cloud management platform for your entire hybrid cloud. Unity manages your data centers, your private clouds from VMware, OpenStack, Hyper-V, and your public clouds, Amazon, Google, Azure. And it manages all your hybrid cloud assets, starting with cabinets and physical data center racks and power distribution units, to physical and virtual network devices from Cisco, Juniper, F5, Palo Alto, Citrix, etc., to your bare metal servers, to your hypervisors, whether it's VMware, OpenStack, Hyper-V, could be Oracle VM, to your virtual machines, whether they're on private clouds or on public clouds, to containers, whether you're using native Kubernetes or you're using GKE, EKS, AKS, managed Kubernetes instances from public clouds, to mesh services, whether you're implementing open source Istio Service Mesh Manager, to Google Anthos Service Mesh Manager or an Amazon App Mesh Service Mesh Manager, to your serverless functions, whether using open source Knative, to a managed service like Cloud Run from Google or Fargate from Amazon. We're now going to log into Unity, the multi-cloud management platform. The login page of Unity takes us into this multi-cloud dashboard, which gives us a comprehensive view of all the infrastructure under management for this customer. So you'll see this customer has various private clouds with VMware, OpenStack. They have public clouds with Amazon, Azure, and Google. They have three service mesh managers, one with Anthos, Google Anthos, open source Istio, and Amazon App Mesh implemented for managing service meshes. They have two data centers with physical racks, devices. We can actually see how many devices are turned on or off, what is the actual temperature, how much power they're utilizing, and get a view of all their devices under management. So in this case, we are going to use the customer's infrastructure in their data center. For a VMware private cloud, we're going to use some of their infrastructure on Amazon and some on Google to implement this specific customer use case. So we're going to first log into their data center. And in this case, we have a cabinet here, which we're going to log into. And we find that as this cabinet shows up, we see the devices they have in their cabinets. We see what are turned on and off. We can go look at what their individual device performance is. And we find that we have this bare metal device called Rose, which has been on for a long time. So we are now going to actually, before we start implementing Service Mesh on it, recycle this specific device. So I'm going to go recycle, reboot this specific socket and to reboot this device. Next, we're going to go configure their private cloud install. So we're going to go to the private cloud setting here. We were going to use a private cloud called vCloud Demo. Now within this private cloud, we see we have a lot of assets. We've got 10 virtual machines. We've got some other specific assets. So I'm going to go into their virtual machines and get a list of all the virtual machines under management in this private cloud. And we see that we're going to use these two VMs, UL Site B Proxy 1, UL Site B Web 1. Web 1 seems to be healthy and alive. I'm going to turn on Proxy 1. Let's go log into this. And now we're actually going in, turning on this device in the private cloud. So while that's being turned on, let's go configure their Amazon footprints. I'm going to go to public cloud, go to Amazon. We wanted to pick the North Virginia, US East region. Let's go look at what infrastructure we have out there. We have a few devices under management here. So we have, in fact, we're going to use 5919 and 7771. So let me go turn both of them on. So we have these Amazon VMs turning on. And while that's happening, let's go to Google Cloud. And we were going to use US Central as our region. And let's look at what infrastructure we have in US Central. We are going to turn on, we're going to use these two devices, the UL GCP Proxy 1 and the Web 1 devices. They both turned off. So I'm going to power both of them on here. And so these devices are going to turn on. Let's go make sure we have, we understand what's going on. So we have, we just get an activity view here, and we see that both Proxy 1 in vCloud has been turned on, the Amazon devices have been turned on, and the Google devices have been turned on. So looks like the infrastructure we need is now ready to be used. And let's go look at what service mesh managers we have under management. I'm going to go to services. We have 3 service mesh managers registered: GCP, Anthos, Istio, and App Mesh. We are going to use GCP Anthos. So let's log into this service mesh manager and let's understand what services. We do have 3 services. We have configured the backend service and the front-end service, and let's make sure that they're performing. And this is going to view the backend service is set up as a network endpoint group, which points to 3 different virtual machines, one on Amazon, one on a private data center, one in Google. So that looks good. Let's go make sure we have our front-end service set up. So the front-end shopping cart service should also be set up across 3 different data centers. There is an egg which is coming up live, and that is showing up to go to both the Amazon, the data center, and of course also Google. So we have 3 backends set up for both our services under management. And at this point, we know our service mesh is set up. We can go check if this application is actually live. Next, we're going to run this application. We'll set up this application on this IP address here with specific markers on the web page to tell us where this application is running. So if you see Amazon North Virginia, which means the front end of the application or the web applications running in Amazon on the East Coast, and the application or the back end in this case is also running in Amazon in North Virginia on in the East Coast. And you can keep running this application again, and we'll come to know where the intelligent traffic management using Anthos is sending the traffic for these specific services. In this case, the front end is going to GCP, the back end is also going to GCP. We run it again. In this case, the front end is going to the customer data center. The back end happens to go to Amazon North Virginia. And if I run it once again, we're going to GCP in the front end. The back end is going to Amazon on the East Coast. And in this case, both the front end and the back end stay in GCP. So we can keep running it. And intelligent traffic management using Anthos is sending the traffic for both those service layers to the appropriate regions. Next, to demonstrate that we have implemented true service resilience and active-active DR, we are going to start killing different services in different regions. And we expect that the intelligent traffic management and service mesh renders itself into a very robust implementation that the service, as the customer sees it, continues uninterrupted as we see different services in different regions start being turned off, but the customer doesn't experience them then because the traffic is diverted to the available services in different regions, and the service availability from a customer perspective is maintained. So we are actually going to go into, let's say, the private cloud first. We had implemented this in vCloud demo. Let's go look at the virtual machine. We're going to turn off the proxy, or let's turn off the application. This is the Web1 VM. So let's go turn this off. Let's make sure I have the login credentials. I'm going to go turn this off. And we can go back and look at our application. So let's just make sure it's turned off. I'll go to my activity log. It's still turning off, so it might take a minute or so to turn off, and then it'll show up here. But in the meantime, I'm actually going to go to the application and see how it's performing. So here's a view of what's happening. You'll see that the application is being served by 3 regions: US West Data Center, US Central GCP, and US East Amazon. And we're going to simulate different users, and we're going to look at where the traffic is being served at each service tier. So in this case, user 1 goes to GCP and then the data center. User 2 goes to GCP, then Amazon. User 3 comes to the data center, both at the front end and the application. User 4 goes to GCP, then Amazon. User 5 comes to Amazon. User 6 goes to Amazon and then GCP. Now that we've turned off the application in the data center, let's look at user 7, for which the front end is served from the data center and the application is served from GCP. User 8 goes to the Amazon front end and the GCP application. User 9 goes to the GCP front end and the Amazon application. So next we're going to go and start turning off services in the other regions. Next, we turned off the front end in GCP, and we see that user 10 was served by the front end in Amazon and then the application in GCP. And user 11 first came to the front end in the data center and then went to the application in Amazon. User 12 came to the front end in the data center, went to the application in GCP. And user 13 came to Amazon both for the front end and the application. So next what we did was we went and turned off the application in Amazon, and this drove the user to use the front end in the data center and the application in GCP. This is user 14. And user 15 first came to the front end in Amazon and then the application in GCP. And next what we did was we actually went and turned off the front end in Amazon, and this led the user to come to the front end in the data center and the application then in GCP. And user 17 had the same path. And this is the only viable path. But as you will see, that a large portion of the infrastructure serving this application across the regions is actually currently down. But the user journey continues to be successful as services which are available in different regions are stitched together through intelligent traffic management to deliver high availability to the customer. So this is actually a great example of using service mesh to deliver active DR, service resilience across regions, service resilience across service tiers, and doing this all with a quick deployment and using modern DevOps and global load balancing, using Anthos into a traditional 3-tier application in a true hybrid configuration, which represents much of the real world where there are significant footprints in data centers and there are customers who want to expand into certain geographies using public clouds, but want to be able to leverage a modern DevOps services like Google Anthos into very traditional architectures like 3-tier architectures in real world hybrid cloud configurations.